This video is about propositional logic, the branch of a formal logic that studies statements that can be either true or false after 5 connectors and 5 truth tables, and you will be able to understand all of it. Then we use it for a sentence that should not exist. Here is a sentence. Read it carefully, because in about a minute, it is going to hand you the moon. Step 1. Assume the sentence is true. If it is true, then what it says has to hold. And what it says is, you own the moon. So assuming it is true gets you the moon, which means the sentence itself, if this is true, then you own the moon, is true. But now we know it is true. And a true if-then, with a true front half, hands you the back half. You own the moon. Every one of those steps is legal. Exactly one of them is not. By the end of this, you will know which one, and you will be able to say why. Forget the moon for a second. Everything we are about to build sits on one small idea, a sentence that lands on true or lands on false, not both, not neither. It is raining. Right now where you are, that is either true or it is false. It qualifies. 7 is even. False, but false is a verdict. The bus is late. Also fine, close the door. What time is it? You cannot call either of those true. There is nothing there to be true. So we sort. True over here, false over here, and everything else gets thrown out, except there is a third bin. It is empty for now, and I am not going to tell you what goes in it yet. Some of these cannot be taken apart. It is raining is just one claim. There is no smaller sentence hiding inside it, so give it a name. P, and here is another one. Q, the bus is late, 2 bricks. Now stick them together. It is raining and the bus is late. If it is raining, the bus is late. Same 2 bricks both times, only the word in the middle changed, and it changed the claim completely. Which gives us the rule the whole video runs on. The truth of the whole is decided by the truth of the parts and the joiner. There are 5 joiners. 5. That is the whole language. Here is how I want you to picture them. A switch for P, a box for the joiner, and a lamp on top that gives you the verdict. First box, negation. 1 input, 1 job. Throw the switch to true, and the lamp goes dark. Set it to false, and the lamp lights up. Do that for every setting, and write down what happened. 2 settings, 2 results. That is a truth table. It is raining is true, so it is not raining is false. Nothing surprising. Yet. Though, watch this. Wire the lamp back into its own switch. Never settles. Hold on to that. Second box, and 2 switches now. It is raining and the bus is late. For that to be true, you need both, rain and a late bus. 2 switches means 4 settings. Run all 4. Only 1 row lights the lamp. 1 out of 4. It is the most demanding joiner we have. Third box, or. It is raining, or the bus is late. Now you only need one of them to go your way. 3 rows out of 4. Where and was demanding, this one is generous. And notice the top row. Both true, still true. This is not the super salad, or where picking both gets you a look from the waiter. Here, both is fine. Fourth box. This is the one the whole video is actually about. P arrow Q. If P, then Q. P is the setup. Q is the payoff. Concretely, if it rains, I will bring an umbrella. Treat that as a promise I made you. Now, when have I broken it? It rains. I show up with no umbrella. That is the one. That is the only way I have lied to you. It rains, I bring the umbrella. Kept. Obviously. But what if it does not rain? I never said what I would do on a dry day. The promise was never tested, so it was never broken. Not broken counts is true. Which is how you get this. 1 false row out of 4. And look at that bottom row. No rain, no umbrella. And logic calls that a kept promise. That row is going to cost you the moon. Fifth box, and then we are done collecting. If and only if. P, if and only if Q is true when the two of them agree, both true or both false. Picture them bolted together. Move one, the other has to follow. Pull them apart, and the lamp goes out. 2 rows true, 2 rows false, perfectly even-handed. 5 boxes, 5 tables. That is genuinely the whole toolkit. And it is enough to break something. Some sentences do not need the world's help. It is raining, or it is not. P or not P. Run both settings. Lit. Lit. There's no way to make it false. 2 true by shape, not by weather. Sentences like that are called tautologies. Flip the joiner and you get the opposite. It is raining and it is not. Dark. Dark. A contradiction. That word does a second job though. And it is the more useful one. If a chain of reasoning ever lands you on 0 equals 1, you have not discovered something amazing about 0. You have discovered that something you assumed was wrong. Contradiction is logic's alarm bell. It does not tell you the answer. It tells you to go back, which you can turn into a weapon. Assume the thing you want is false. Follow it until it says something absurd. Then the assumption was the absurd part. Remember that move. We are going to use it twice. Now, back to that bottom row. Whenever P is false, the arrow lights up automatically. Does not even look at Q. So, if the moon is made of cheese, then 2 plus 2 is 5. In logic, that sentence is true. Both halves are nonsense and the sentence is true. A false setup gives the arrow a free pass. It works from the other end too. Whenever Q is true, the arrow lights up, whatever P is doing. If the sky is blue, then Paris is the capital of France. True. And the two have absolutely nothing to do with each other. Which is the thing to hold on to? The arrow never checks whether P has anything to do with Q. It only checks one thing. Was the promise broken? Let us push it. Take P and build. If P, then Q implies P. 4 rows. Every single one lights up. It is a tautology. Same status as it is raining or it is not. True? no matter what the world does? Read it out loud. If my keys are in the freezer, then water being wet implies my keys are in the freezer. Implies does not mean has anything to do with. And that gap between what the arrow checks and what it sounds like it checks is exactly where paradoxes hide. This is Beaky. Beaky is a parrot, and in his entire life, he has said exactly one sentence. Beaky is lying right now. Suppose it is true, then he is lying. So the sentence is false. Fine. Suppose it is false, then he is not lying. So the sentence is true. You have seen this before. It is the lamp wired into its own switch. Neither answer survives. Not true, not false. There is no verdict there at all. Which means it fails the very first test we set. It looks like a proposition. It is not one. And now that empty bin gets a label. Sentences about their own truth. Which brings us back here. Call the sentence C, and call you own the moon M, which is, we can agree, false. C says, if C, then M. But C does not just talk about that. C is that. The sentence and its content are the same object, which is a biconditional. C, if and only if C arrow M bolted together. Suppose C is false. False setup, free pass, so C arrow M comes out true. But C is bolted to that, so C is true. Alarm bell. So suppose C is true, then C arrow M is true, and its setup C is true, so M is true. You own the moon, you do not? M is false, so C arrow M is false, so C is false. Alarm bell. Both suppositions eat themselves, exactly like Beaky. C has no truth value. Which is the crack. Go back to step 1 of that proof. Assume the sentence is true. You cannot. You do not get to assume a sentence is true until it is the kind of thing that is capable of being true or false in the first place. You do not own the moon. 5 joiners, 1 table each. That is all it took. And 1 sentence that never had a verdict to begin with. Logicians did fix this, by the way. The fix costs you something. And I will show you what next time. Be sure to like, subscribe, and watch the next video.